Hello everyone, I'm Mohamed Yoonus. So today we are going to discuss about a new topic called Data Encryption Standard, or simply we can call this as DES. Data Encryption Standard is actually a symmetric key block cipher. When we call something as symmetric, we know that symmetry is we just use for some kind of even thing, some kind of similar or like things. So in this case also, the key that we are using in the input and output is actually similar for the encryption method. The DES, the idea of DES, it is actually developed by the company IBM in early 1970s, which is actually based on host facial design. It was actually submitted to US government for the in response for the call protection security kind of algorithms. DS is implementation of facial cipher. Okay, this is an important point. We can discuss about the 16 round facial structure in the coming slides in very thorough way. And also there are some kind of rules that we have to follow when we do this kind of encryption methods. Okay, so we will be having 64-bit block size. We will be the key length is also will be 64-bit. The effective key length will be 56, where the 8 things will be will not be used. Like kind of things we have to discuss. There will be 16 rounds and all. We will discuss all those things in the coming slide. And as we already said that the DES is actually based on facial cipher. Uh, it is actually all that is recorded specified here is these three things, that is round function, key schedule, any additional person like initial and final permutation. Okay, so this is just an introductory part for the DES. We can look what exactly is DES means in the coming slides. So here we can see that we are having a 64-bit plain text on the left side and a 64-bit uh, plain text. Oh, sorry. Okay. So a 64-bit a key in the right part. So here we can see that in this 64-bit, when we are giving this to a permuted choice one, that we can call this as PC1. Okay, so when we give a 64-bit into this PC1, we will get an output of 56 bits. So what is actually happening is that when we give 64-bit key into a PC1, it just compressed into 56. That is, 8 bit will get removed. 8 bit will get removed. Okay, 8 bit will get removed. So after that, the output of PC1 will be like 56 bits. So how is this 8 bit is getting removed? It is like the every 8th bit of the up to 64 is getting removed. That is like maybe like 8th, 16th, 24th, 32nd, 40th, 48th, 56th, and 64. Likewise, it is getting removed. So after the PC1, the compression, it will be like 56 bits. And after that, we will be having another permuted choice like PC2 here. So the input of PC2 is 56 bit. So similarly, the output of this PC2 it will be 48 bits. That is, another 8 bit will get removed. So here we can see that it is 8 into 6 bits. That is 8 into 6 is equal to 48. So which means that actually 8 into 6 bit means like it is like 8 blocks. We will be having 8 blocks and 6 with 6 bits each. Okay, so that is the literal meaning of 8 into 6 uh, bits. Okay, so we are actually giving all these things into the round one. Similarly, we will be having and another second circular left circular shift. So it will shift into permuted choice. The result of the permuted choice one will be will be similarly shifted will get shifted into the corresponding or respective permuted choice in the coming order, like from the first to the 15th or 16th part. Okay, first to the 15th, 16th. So that is actually happening here, and it will give into the corresponding round. So there will be like 16 rounds and 64 plain text, 64-bit key, and 32-bit swap. Okay, so here we will be having the plain text. So we are actually using plain text can be anything that we are giving in the input part. It might be like a hello India or hello Raju, like kind of things that we want to sign for. Okay, so we will be divided into 32-bit into two parts, and we will give into the initial permutation. We can add this step before this if we want. So initial permutation means nothing. It will just rearrange the order of whatever we given in the input part, and it will give it into the round. So this round is actually the core part of DES. Okay, so round is the real core part of DES. So we can discuss about what actually this round does in the coming slide. Okay, okay. So here we can see that uh, there are having 32-bit L I equal to 1 and R I equal to 1. So L1 and R2 is equal to 32 bit. So how this is happening is like we are having 32-bit text here and another 32 bit. So 60-bit it is actually classified into 32 and 32. So let us assume that this is L and this is R. That's how we are actually getting two input like here. So what is happening right here is we are giving the left input directly into the XOR gate, and here the right input is actually having 32-bit is giving into an expansion permutation unit. So what is the result of expansion the permutation unit? When we give 32-bit into expansion permutation, let us write it as EP, we are actually getting 48-bit in the output. So what happens if we give this into an a CP, that is, or a permutation computer compression, or PC, whatever we can call. Okay, so what happens when we give it into PC? It will just compress the data that got. But in the case of expansion permutation or the E table, sorry for that, or the E table, the result will be like increased bit data size. Okay, so the XO gate input is one part is 48, and here we can see that we are having C1 and D1, and it will be having left shift S, and we will be giving into the permutation contraction, that is PC2. We know that the PC2 input is 56, that is 56 means 28 and 28. So this 56, like we can see here, it is 56. So before giving into PC2, right? So this 56 is like 28, 28 is divided like that. So this 56 is given to PC2. The output will be like what? 8 will get reduced, and output will be like 48, right? So in this XOR gate, the two outputs are same. It is, that is 48 and 48. So the answer will be like 48, right? Okay. So here we can see a thing called substitution choice, or S box, which is very important in the DES part. Let us understand that very detailed. So let us assume that we are actually getting an result like drawing. Okay, so let us assume that if this is the result that we got in when the purpose that we're doing. So let us take this 1 and 0. This is actually a 6 digit number, right? So the first and last digit we have to take consider for taking a rows. Okay, for the row thing we have to take the first and last digit, that is that number of rows will be there. So we are having 2, so the equation is like 2 raised to n. So what is the number of n here? It is actually 2 raised to 2, which means that 4 rows will be like there. So we can, when we draw the table, it will be like this, 1 2 3 4, that is from 0 1 2 3, from 0 to 3 rows will be there. And in the case of column, we know that how many digits is actually left here. It is 1 2 3 4, 4 digits are actually left here. So 2 raised to 4 is equal to 16. 16 digit will be the 16 will be the length of column. So we can say that from 0 to 1 2 up to 15 will be the length of column. Okay, so if this is the answer that we are getting while we doing, that is 0 1 1 1 0 1 0 0, sorry. So when we are actually converting this into the decimal format, we know that this is 2 raised to 0, 2 raised to 1, 2 raised to 2, and 2 raised to 3. This is 2 raised to 2, right? That is 2 raised to 2 is 4 is the answer. So we have to write this 4 in the some box, so we don't know which box we have to write it, right? So here we can see that when we convert this, we know that we are taking this 1 and 0 like for what, for the row purpose, right? So when we convert 1 0 into a decimal format from the binary to decimal, it is actually 2, right? And also in the case of 0 0 0 0, when we convert this 0 0 0 0 in the column to decimal format, we will get 0 in the decimal, right? So what happens is that from the zeroth column, that is in this column, and second row, that is this one, we have to write the answer 4. Okay, here so 4. So that is what actually is happening in the S box. So this is how things are getting done here. So after that, it will be having a 32 bit, and it will get permuted in the fixed order. Will be an order that is already specified, and the output will be also a 32 bit, and it will be given into an XOR. So we have to understand one thing is that the here also the input is 32, and here the output is also input is also 32. How this 32 is coming? This is just from this 32. Okay, so it is actually given directly, and the output will be what, it will be also a 32 bit, because what, two input is one, I mean are same. Okay, and after that, this is what actually we are doing in the what part, in the round part, or the core part. So here we can see that after that we are having a 32-bit swap. So why are we using swap? We are actually swapped right here. Okay, right. So we have to just interchange all the things that we have done. We will be using a 32-bit swap. After that, we will be having an inverse permutation where we will do all the things that we have done in the reverse way. Like, and after that will be the output like in the in the 64-bit ciphertext format. Okay, that's all. So this is all about DES. Thank you. Thank you for listening.